Good day, everyone. My name is Etienne Lowe. I'm the Operations Director of ZA Space, and it will be my pleasure to be introducing the expert speakers over the next 2 days. Please note that any questions can be asked in the Q&A tab during the presentation. Our first speaker is Sven Gilliams, who will be speaking on the critical role of EO in agriculture, opportunities, restrictions, and priorities. Sven is R&D Project Manager at VITO. Sven has 20 years of experience in Earth observation and its applications for agriculture. He has a background in agricultural engineering and has been working in the remote sensing and agricultural domain since then. In 2005, Sven joined the VITO Remote Sensing Unit. Currently, he is responsible for the business relations of the Remote Sensing Applications Group, but mainly working on agricultural projects ranging from global agricultural monitoring and mapping to local precision farming, combining, amongst others, Copernicus Earth observation, Mapio, and in situ data sets with artificial intelligence. Sven, over to you. Thank you very much.
Yeah, thanks, Etienne. I'll share my screen to move into the presentation. I hope everybody can see it now full screen. Should be good. So Etienne, thanks for the introduction. So my name is Sven Gilliams. I work for VITO, and it's actually a pleasure to present here in this industry track. I was last year in Canberra in the industry track where I presented some of our work. Was very nicely organized there in Canberra. So I'm very glad that now in this virtual world we're also doing an industry track where I can present. But I'm looking forward to meeting everybody in person as well. Hopefully next year when all this pandemic has died a bit. So I was asked to present in the next 30-35 minutes my ideas on the critical role of EO in agriculture, opportunities, restriction, and priorities. I'll focus on the priorities. So my presentation, I'll firstly give a short introduction on VITO for the people that don't know VITO, then on the changes of EO in agriculture over the past decades, EO opportunities, and then some of the challenges. So VITO, who is VITO? I know the focus is on SMMEs, but VITO isn't really an SMME. We're an independent research company based in Belgium. As you can see, we're around 1,000 people strong, so that's not really an SMME. But we're somewhere in between research, in between industry, in between SME, so it's a very interesting role to play. What we do is we de-risk innovation for companies. On the bottom side, you see some of our KPIs, which are not very relevant at the moment. Where do we work? We work in all over the world. Our headquarters is in that top there, in that very small country, Belgium. We also have an office in China. We're starting up one in India, and then we have offices in Qatar as well. The dark blue is actually, well, we work at global scale, but the dark blue is where we get funding from different projects. In fact, all our solutions are global based. Where does VITO work? In energy, in chemistry, materials, health, and land use. In fact, sustainable should be in front of all those works, all those topics. Let's put it like that. So sustainable land use is where the remote sensing department is based, focusing on land, water, and air. And like was mentioned by Etienne as well, agriculture is there the biggest chunk of the work. So EO and agriculture. In fact, the basic questions for agriculture, they haven't changed for the past 40 years. And EO always has been, well, agriculture always has been a top application for for Earth observation, for remote sensing, but the basic questions, they haven't changed. And they still want to know what, where, and when. Those are the basic questions. Okay, also sustainable production of increase. We want to monitor our yield. We want to know crop growth. And what is key is the frequency of observations and the continuity. And what has changed is, well, the type of data, and we now have drones, we have better satellite, and the amount of data has greatly changed, but the key questions, they haven't changed. And one of the main, or one of the key contributors to that big change in EO data, and where we see as research company in between SMEs and industry, where a whole lot of new players and new possible applications have been looking at and have been changing the use of EO is Copernicus. So the Copernicus data sets, they have really a big contribution to all this change in EO we have seen lately. And why is that? Not only due to the vast amount of new data that there is, and you see the list of satellites coming up, the number of applications or possible applications, you see the number of satellites, but also the continuity. So on the one hand side, we almost go from when I started doing remote sensing, a data scarce environment, to now we have the abundance of data, big data, actually almost in some cases too much data, in fact. But it's good. And what is also very important is that there is continuity. So there is a clear vision on continuity of the satellites, which is really a great vision there. So people and industry start to invest also into EO and EO applications, because they see, okay, this is not a one-off shot. There is a continuity, which is really great. So due to the amount of data, of course, the typical way of downloading and doing your work on your own laptop or on your own server is not possible anymore. And you can see I'm from a European-based company, so I know the European landscape very well. So this is all okay. The data is you don't have to download it; it's stored on platforms, on cloud servers. This is the view of the European landscape. Of course, I've put a lot of international players there as well, and this is actually a challenge and an opportunity. The challenge is, okay, if I'm an SME or a company, okay, if I'm going to build a service, where am I going to build this service on? On which platform? Which platform to use? What are the pros? What are the cons? Do I get myself locked in or not? Those are typically questions that people ask. But there, for industry, there's an opportunity. You can play that role of facilitator. Another big benefit is you don't have to invest in infrastructure anymore as an SME. You can run your service on whatever cloud you have selected and run the stuff. This is also a huge benefit. Then, of course, next to, okay, we have the data, we have the platforms, but of course we need the knowledge as well. And there is already a huge knowledge available within EO and agriculture. And I think Gilberto mentioned this morning in his talk, all the open source data that is available, which is great, because I don't need to start from scratch as industry when I start developing. I can build on what is already existing. And here also Geo and GeoGlam plays an important role. They're building up this geo infrastructure with the knowledge hub. So actually, in case of GeoGlam, and that's the view that we're having, it's almost going to be a one-stop shop of, okay, I want to do something Earth observation, agriculture. What is there? What is existing? And where can I build up? And that's the idea, and that's a huge benefit for industry. Of course, there's also it should be not only unilateral but bilateral. So also when industry can contribute, that would be great. And then based on all these things, we come up with new products and new opportunities. And I'll just go through this with a couple of examples of things that we were dreaming of 5 to 10 years ago and that we're actually doing now, and how we can actually build on top of that. First one, this is purely a Copernicus service. So the Copernicus global land cover layers. It's really a product that's now available from 2015 until 2019, 2020. We're creating now, and this is a global land cover layer at 100-meter resolution. The interesting part is that it's not a hard classification. Well, it is a hard classification, but underneath there's also a continuous layer with classes, and that you can actually adjust the borders between the classes, so you can create your own land cover map based on your own parameters. You can see, like, you can create a forest map, you can create a biodiversity map, you can create a land cover map specific for agriculture, and that's all based on discussions of definitions. What is a forest? What is a agricultural land? We have been discussing that within GeoGlam for quite some time. What is agricultural land? We had with the JCAM sites, we had a definition. It recently changed again, so all these changes can now be adapted. But of course, this is based on the Copernicus dataset, so the 100-meter. But we're moving that into the Sentinel-2 and Sentinel-1 era, so now to 10 meters. So that's a project that we're also working for ESA. It's called World Cover, and you will get a 10-meter resolution map at global scale within 2 months after the end of the year. So it's really fast and accurate production of those maps. What you see here, of course, is just some zoom on what is possible. So that product will be ready mid next year. So the 10-meter product at global scale. What is interesting now, of course, for EO and for industry and for SMEs, that is actually a product with a 10-meter resolution of cropland at global scale. So here you can start building your own service. You don't need to start doing a land cover classification. It's going to be an open and free product, part of it will feed into GeoGlam. It can be used for the crop monitor, for whatever GeoGlam services that we want to develop. But this is going to be a base layer that is open to anybody, and that people can actually start working from, which is ideal, which shortens my investment, and I can start building services on that. Next to that, another project that just started up. It's called World Serial. Yeah, it's one of the 4 World Series, as ESA calls them, projects. So yeah, World Cover, World Serial, World Water, World Soil. World Serial is really dedicated towards agriculture. So also there, we need to develop cropland map. The difference between the World Cover and the World Serial cropland map is that this needs to take into account, so in World Serial, we need to take into account seasonality, which is not the case in the World Cover. So seasonality, and there's a focus also on crop type, and irrigation is in there. This one has just started up. We're now getting or benchmarking the different algorithms. We're getting the first results. Key here is also getting in situ data to train the models, and that's a point that I'll be coming back to, because open and free data is really nice. So we have the EO data, we have the knowledge, we have the platforms. It would be great if everybody would share their in situ data as well, so that we can build on that as well. Another example of of a product that we're building up thanks to that new and vast amount of data is a combination of data sets. So agricultural monitoring has always been, well, clouds have always been a problem. On an average day, you have 67% of cloud cover at the global scale. So if you want to monitor a field, you can't say to a farmer, or you can't say to industry, sorry, no information. There was a cloud, so we don't have any information. So what we did is we combined optical and SAR data, which gave us a simulated uninterrupted Sentinel-2 vegetation index, which allows us to really monitor a field on a weekly, 5-daily basis. And that's being implemented operational. And it was first developed in Belgium. And I know Belgium isn't a big country, so you don't need any platforms. You can still download all the data. But we also developed it as a service, and we tested it, and we were able to transport it to anywhere in the world thanks to the platform. So that's also something very important where industry can build on. You can start by working very local, but as long as you do your development correctly, you will be able, thanks to all the platform technology, you will be able to implement it anywhere in the world, which is a huge success for industry as well and SMEs. So actually, those things, the data availability, the combination of data, actually has contributed quite a lot to the, how do you call it, digitalization of agriculture. And the right-hand side of the picture at the global and regional trends, that's really stuff that we've been doing for the past 20 years. Only the resolution, the amount of data has changed quite a lot, but the methodologies didn't change that much. Okay, there was artificial intelligence now coming up and stuff that's changed, but in principle it's still basic, and that's really where all the information goes into GeoGlam. But on the left-hand side, you had really all the seed breeders, all the genotyping, and that was actually really purely in situ field data based. And what is interesting now, that with drones, with the new technologies, you can already start supporting those companies as well. And by linking all those different, let's call them resolutions, you have the whole flow from left to right and right to left of data sharing. And so all the data goes into, at the end, to the global scale or the local scale. And this is where the interesting part is, all the combinations of those different data sets and really monitoring what is going on. And we developed a couple of platforms to really monitor that, well, the progress or to support the industry. And let me go into those platforms. The first one is Mapio here, which was originally developed as really support for genotyping and phenotyping, where you could have independent SMEs, drone companies, just fly over fields, and they could upload their data. It was processed, it was visualized, it was analyzed, and was sent back as a report or an image or whatever. So actually, industry or small SMEs, nothing to do with remote sensing analysis, could really just fly, upload the data, and provide information to their customers. The impact for, on the one hand side, an SME, they could just fly and don't need to take into account all the processing of the remote sensing data. But also for the industry, they could test much more of different varieties. They come up with twice as fast results on their varieties. And they have much more time and budget available to to start asking other research questions, where then again SMEs can play into and support them with those questions. Questions like, okay, I have this variety, I want to check where those varieties are illegally multiplied. An example of a question that we're getting now based on this. And there you see the flow from that very high resolution to high resolution to then eventually global scale. Other example, I'll go quick on this, is Watch It Grow, where we have actually the combination of Sentinel-1, Sentinel-2, but also with remote with Mapio data, with yield models to come up with predictions at field level. What we also did here is combination with in situ data, and actually try to collect as much as in situ data from the farmers to better train our models. We have an agreement with industry in Belgium, the potato growing industry in Belgium, that actually when farmers upload in situ data into the system, they get some kind of compensation, monetary compensation for that in situ data. So that's a way to share and collect in situ data in this system. Again, this is not a new model, not a new system. There have been crop monitoring systems for 15 years. What has changed now that it's operational due to the fact that we have this kind of data availability, in situ data availability, and combinations of different data sets, which makes it operational. Then going into some of the global applications. Here I'm talking about the agricultural stress index system of FAO. This is based on low resolution data. It's global scale. This is stuff that feeds into Gilliams crop monitoring information. But on the other hand, it also feeds into industry and SMEs, because these drought indicators, they're used to help industry on more detailed drought monitoring. So you can look at regional scale, where are the drought areas, and go into more detail with more specific information and support industry. So actually, all the next examples, I'll just show the contribution to GeoGlam, or the input to GeoGlam, and where industry can use that information based on the new data, on the knowledge that is available, and on the platforms. Another one here is on water use efficiency, monitoring water in agriculture. This is also an FAO service, also feeding directly into GeoGlam. At the moment, the service is dedicated towards Africa, so it's at continental scale. It's actually at different levels. So you have continental, you have river basin, and then in details in 6 or 7 countries in Africa, where at the end of the day, you want to have information on water productivity. This information feeds into national governments, but also industry or SMEs can actually develop services based on this open and free database on irrigation management. And that's actually what we see happening in some countries. Part of that product is also the differentiation between rain-fed and irrigated croplands. So there's a number of layers in the product. So one is on land cover data, where we work based on that Copernicus land cover data. We then refine it with the difference between the croplands in irrigated and non-irrigated croplands, and in that irrigated and non-irrigated, you get water use efficiency, biomass, crop type, etc., and information. And that's all in the database. And anybody has access to the database, and you can start building services around it. Of course, agricultural insurance is a big one. we've been doing, there's a number of tests on historical archives, on new indicators, on index-based insurance since 2000s until now. Also here you see the influence of the Copernicus datasets and new possibilities arising. On the one hand side, you have all the direct insurance, but also the reinsurance that's really looking at this kind of information. An application we developed for a company called Pula Insurance, where they have quite a lot of agricultural insurance how do you call them? A big agricultural insurance portfolio in East and Southern Africa. And they were asking on index insurance, but also a way of reducing their field visits and how to organize their field visits. So what we did is based on a platform, in this case, ESA's food security tab, and the knowledge of all the information that we had on index-based insurance with low and medium resolution data. We developed a platform for them where they can actually monitor their fields. And so they upload on a server, they upload the locations of their fields. So those are the blue dots on the bottom side of the picture. And for all these fields, you get information on crop growth based on CropSAR technology, but also you get all the metadata that is available, which is actually also available through that platform. And you can start really doing a ranking of the fields, comparing fields, seeing which fields are performing better, which fields are performing worse, and also see if that's due to management or due to meteorological circumstances, where there is a need for a field visit and where not. And that wasn't possible before Copernicus and before the platform technology. And also here, this is now a demonstration for Pula, but this is a methodology that now can be implemented anywhere in the world because we have access through the platform to all the data and the metadata as well. Then, of course, the platforms and which platform to test or to use, it's a big question. Also within GeoGlam, because GeoGlam is actually having that wants to move more into operation, more on sustainability, and so we need to use platforms. But those platforms, which ones to choose, how to choose them, and whatever, it's a big challenge and something that GeoGlam with its federated approach on IT is really looking into. And so there are a number of research activities that support those things. Here is an example of a project, eShape, Horizon 2020 project eShape, where based on GeoGlam's EAV is an essential agricultural variable. It's a variable that is linking GeoGlam work with all the policy. Crop calendar is an example of an EAV. Cropland is an EAV. There are a number. We'll be coming up with a list pretty soon. COVID has influenced that a bit. We would have hoped to be ready by now. It's going to be early next year with that analysis. But what we're doing now here in this eShape test is, okay, on the one hand side, we want to see how good we can come up with the crop calendars. So that's the research part of it. On the other hand, we're also going to test this implementation on different platforms. So that will give GeoGlam and the community and also SMEs in the community an idea on how certain platforms perform on certain conditions. So that will provide information on what to choose, which platform to choose your algorithm, to implement your algorithm Another example for scaling, because, okay, there are, of course, in the GeoGlam and GeoGlam knowledge hub and best practices, there are already a number of examples of software available or coding available, and also open source coding that is available, but you will need to be able to scale it. So on which platform are you going to do that? Who is operating those? What are the results? And this is an example from another European project, NextGeos, where some of the essential biophysical parameters are calculated. So that's actually a platform where people can go to run an algorithm and download the results or view the results or whatever. So there are a number of these platforms that are being tested and are being used operationally in GeoGlam as well. So those were some of the opportunities where you can clearly see that contributing to GeoGlam, or products that contribute to GeoGlam, also industry can benefit from them, but also the other way around. Industry can also contribute quite a lot to GeoGlam as well. One of the challenges is, like I already mentioned, the platforms in Europe. We have a scattered landscape. Some people say that it's a benefit. Other people say that it's a challenge. Next to the European fragmented landscape, you have all the big players. So as an SME, it's not always easy to know which infrastructure to choose. As an end user, it's not always simple to know which infrastructure to use. There are a number of applications that try to solve that issue already. There's research being done on OpenEO. That is software that makes your algorithm cloud independent. The tests that we do for eShape on GeoGlam, depending, checking the performance of the different algorithms and sharing the results, that will contribute quite a lot. And then also another example is ESA World Serial, as I mentioned. The actual goal there is to develop an open and free software tool that is completely cloud independent. So all the algorithms that we will use to come up with global crop type map, they are going to be cloud independent. So that means that you should be able to implement them on any cloud infrastructure whatsoever. So I think that's really an important step also there when developing, to look at to make sure that you're not locked down in one system. What are the priorities? It's clear, open and free data. That is to me clear. Knowledge management, so sharing and making it available, because there's a difference between open and free, and then also availability. Where I see the biggest challenge at the moment is still in the in situ data, and the figures that you see on the left of the slide is something that we've been doing for World Serial, because with the whole benchmarking on crop type classification and cropland classification, the global scale, we need in situ data quite a lot. So the top map is where we already have in situ data. The dark greens is the full country. The light greens are parts of the country. But of course, there's much more in situ data available, and so this is really a shout out to get back to me. And if you have in situ data somewhere from let's say the Copernicus era, and let's say from 2017 onwards until now, that would be great if we could use it and share it. Because at the end of the day, it's also a goal of World Serial to come up with that a global in situ database for land cover, for crop type mapping. World Serial is just a project, so after 2 years it will end. but the logic is that once that database is available, we will of course put it in where it should belong, in the GeoGlam Knowledge Hub, and there it becomes accessible to everybody who's interested. Bottom part is data sets that are almost ready to be integrated in our data set, but there is much more. So coordination of those networks, to me, that's GeoGlam, but there are also initiatives like Radiant Dirt and etc. that are working on that. We have collaboration with them. We have collaboration with GeoGlam. We just need to see where the best fit is. And I think with that, I would like to thank you for your attention. And if there's any questions, please let me know. I'm not seeing any questions at the moment. So if there's no more questions, I think we can move to the next session. I would like to thank you for your attention, and you feel free to contact me if you have any more questions afterwards, or if you have very nice in situ data sets, feel free to send me the information so I can bring you into contact with the people in World Serial that are responsible for in situ data and in situ data sharing. So with that, thank you very much. Enjoy the rest of your day, depending on which part of the world you're in. I think in 5 to 10 minutes, the next speaker will start. So that gives you a nice time for a good coffee and be ready for next talk. So thank you very much, and we'll see you soon, hopefully in better circumstances than this virtual environment, although this virtual environment is, well, it's the next best thing than meeting in person. Thank you very much.